Hello, guys. My name is Mark, and my YouTube channel is all about programming for Tone, projects that are related to Tone, and other things related to Tone. And this video I'm sharing with you is a lecture from Hackathon in Prague. The hackathon was dedicated to Tone technology, and this is a lecture of two great minds that are related to Tone. Both guys' names are Oleg, and they're co-founders of Tone Keeper. So watch this video. I really advise you to understand better concept of tone. Have a good time watching this video, and if you like it, please like this video and subscribe to the channel. So have a great time watching.
And so it comes to this idea of multi-blockchain actor model, which is weird. And it's important to understand it better to write the effective applications. So let me give you an example. In Ton, you have some number of users, right? And these users have individual wallets. And those individual wallets are represented by entities that are called contracts on the blockchain. So these are actually smart contracts, like little pieces of state and code that are able to do some computation based on incoming messages and do the outgoing messages to other contracts. So for instance, if I want to send coins from one user to another, I sign a transaction that says, please send some coins to the other user. And in Ton, it's represented by two messages and actually two transactions. So that's the very basic stuff. And the important thing here is that in Ton, each of these contracts is considered actually as a separate blockchain, right? So it's a little bit like weird. Everything that happens within the contract is some number of transactions, and they're tracked as a separate blockchain here. And anything that happens here is also a separate blockchain. And effectively, if you have a billion users, you have a billion blockchains. This is where you start with. And you have a little bit of a protocol logic that allows you to wire together all these messages between them. But from the perspective of each blockchain, those are just separate entities. And when you do something here, you don't have any visibility on other contracts. And this is the key to scalability, because whatever you're doing in a contract is focused right on its own state, and you have no idea what's going on around you. Now, of course, when the load is not huge, when you don't have billions of users, when you have thousands of users, it doesn't make sense to perform consensus work on these individual blockchains, so they're kind of bundled together. So right now in the Ton, you probably know about master chain and work chain and shard chains. So all of these are effectively aggregates for convenience of these individual states. And they are ready to be split up back into the smaller subgroups anytime there is too much load, right? So what does it mean for the developer is that you should think of this still as independent blockchains and don't even consider that right now you have just one work chain or one shard chain. That's like a temporary convenience aggregate that doesn't really affect the design of your application in any way. So in this model, how do we implement custom tokens? So far, this really doesn't matter that these are separate blockchains, because you just transfer Ton coins here and there. Very easy. How do you make a custom token like a stable coin? What if you want to do the USDT? So Ethereum model is this. You create a contract, and in Ton you can do exactly the same thing, and you're not supposed to, but you can totally do. You can create a contract here, well, like this, and call it USDT. And how does it work in Ethereum? You are having a little table. Well, actually, it's not little. It could be millions lines of of accounts, and you keep track of how much each wallet address, so this is A and this is B, how much each user has of these virtual tokens. Like the user A has like 5 units, user B has 10 units, etc. And this is Ethereum model where to interact with this artificial token, you would send messages from the wallet saying, I want to transfer some number of units from this user to the other, and the contract would do the transaction inside itself, and it will have its own little blockchain to update this state. And then the other user would know that, okay, now my wallet has access to more units, and then I can transfer them to someone else. So this is how Ethereum implements ERC20 standard. And this is something that you could easily do in Tone with FunC. Like right now, you have a hash table primitive, you have incoming message, you do some operation, and you may even like create a message that notifies this user, like a little transaction that says, hey, you got the coins. You can totally do that. Now, the problem with this is that this does not scale because now you have like the small blockchains for each user, and you have a big blockchain for USDT that every user interacts with. And whenever Ton does the sharding, then it suddenly sees that I can shard these contracts arbitrarily small. I can have 1 billion shards with just a few contracts in each. But this one will be a monolith. It will be a single huge contract with millions of transactions, and it will live in one shard, and everyone will send messages to it, and so it will be a bottleneck. And if you go to society.ton.org, there's a great article by Talcol that goes in the detail how this works. So I really recommend you studying this article. It's right there on the slides. And I'd like to kind of generalize this idea and kind of explain how it should be done, how it is currently done in Ton, and how does it apply to your applications and how you should design them. So we don't want to do this because it doesn't scale, right? What we really want to do is to, what we really want to do is to keep the contract small and individually controlled. So if you're familiar with O notation, you want every contract to be O1. All right? So every time you feel that there's some kind of list that grows, or you want to do some loop, you want to ask yourself if you're doing this right. So how do you do this in Ton? You kind of need this table. You need to know that, yeah, people have this artificial unit somewhere, but you should use the entire blockchain as a basis for this bookkeeping. So instead of that, you would have this model. Every user has a wallet, and each user has individual contract that we call J because it's implementing the jeton standard, or we could call it a token. So this J contract. And there is a one-to-one relationship between each user and the wallet and each user and the jeton. And within the contract, you have a number. So all these numbers here in the table, they're now split up in this individual contracts. So now this guy has 5, this one has 10, and this one has like 11 as a number in the contract. And whenever we want to make a transfer from the person A to person B, this is what happens. The wallet receives the signed message saying, I want to transfer a jeton or a token. The wallet forwards this message as an internal message to this contract saying, could you subtract some tokens from you and send them over to the other guy? And it sends the address of the other guy, so it's B. And it says, plus credited with 2 tokens. So this contract takes this address B, takes the number, and calculates the address of this contract based on the owner address, and sends a message, please receive 2 tokens. this contract knows that this is a relative of that one. They know that they share the same code, so it trusts that the incoming message is not from like any random application, but it's actually from the same instance of the same contract, but it's physically a different instance, but the same logic, same code. So it knows that by receiving this message, this contract actually subtracted 2 and now has 3. So the contract number 2 knows that the balance was updated correctly, and it can just add 2 on its own side. And then the last message that it sends is a notification message that tells the wallet that, hey, you got incoming token. Now what's interesting here is that you have 1, 2, 3, 4 messages. This is the external message that is assigned with a private key, and 3 internal messages. And you have 4 contracts involved, and you have 4 transactions. This contract had a transaction that processes these 2 messages. This contract has 1 transaction that processes these 2 messages, and so on. So there are 4 transactions and 4 messages that happen that are doing the one job. So why is this so complicated? Who thinks this is complicated? All right. Is it worth it, though? So why is it cool? Each of these contracts has fixed size state, and each contract may live in its own shard chain. So if you have billions of users and trillions of transactions, then the cool thing is that these 2 users have these 4 transactions that don't touch this user and all the shard chains that exist outside these like 1 to 4 shard chains. Actually, people could generate the contracts in a way that to force these 2 to exist kind of closer together and possibly in a 1 shard chain. So this communication would touch like two shard chains instead of 4. But this is a small optimization. It doesn't really matter. What matters is that all of this communication doesn't touch the rest of the network. And so this scales infinitely. Like billions of other users could do the same thing, and they would not intersect and load up this interaction. And you just need to make this sufficiently cheap so you don't really care if there are like 4 messages running around. So also this notification is important because now if this wallet is some sort of like special application, this is the only way to know inside the application that you suddenly have increase in the balance, because you cannot see the balance outside yourself. So if this is a special like DEX or some app, without this message, they have no idea what the balance is. So only by receiving this message from a trusted contract, they know that they received some coins, because this number they cannot see from here. Also, if you're just a plain wallet, you can monitor transactions on your shard chain just for this contract and not care about all the rest. And by observing this incoming messages, you can know what happened with your account. So this is a ultimately very scalable thing, and it raises a few questions on how do you express in your application this relationship between those contracts, because these are actually pieces of one logic. So originally you had just a USDT implementation, like a one file, one system with all the incoming and outgoing messages. And suddenly you now kind of have to break it down in separate modules. And you also have another contract that is called Minter that creates those in the first place. So how to express the relationship between them? So that's a very interesting question. You can see in Fancy how it's implemented. But in short, the idea is that the Ton guarantees you 2 things. First, of course, you have the local state and you have synchronous access to it. But at the same time, it guarantees you the address of the sender of the message. So every time this message is arriving here, this contract knows exactly where it came from. And it's this address of the sender is actually a cryptographic hash of the contract, and this allows that contract to verify that the DNA and code and initial data of that one is the same as this one. So they can have a trusted relationship based on that. So if you look in the Fancy implementation, you will notice that this code, when it receives the message like, oh, could you please increase your balance? It would actually check that it came from the correct contract by reconstructing it from scratch and computing its address. Now, let's make it more interesting, right? So what happens if you want to make something more complicated with those tokens? Currently, we just like sent them around, and we want to add, let's say, a time lock feature for it. For instance, this user wants to buy some tokens and in some investment deal, and we want to sell them those tokens with a time lock and say, you have those coins, well, those tokens, we guarantee you those tokens, but you cannot use them until after 1 year. How do we do that? So one way to do that is to just say, okay, within this contract, we'll just add a condition, some condition here, that says some amount, well, actually it should be two things, sorry. So this is a condition. It says 100 tokens after 1 year. And so if you have 200 tokens, then the first 100 will be free to use, and then the rest will be locked in 1 year. So the question, does this contract, is this contract compliant with our philosophy of O1 so far? Like, is this a good idea to do that? So actually, yes. It's pretty small. It's fine. But there's another problem. It's not quite composable. Because what if you have another token that, let's say you have euro tethered, and this is USDT. Now, this one was deployed a bit earlier, right? And it doesn't have this feature. And now you have two tokens that are kind of like the same functionally. You can transfer them around, but one token has ability to be locked and another one doesn't. So how do you add this functionality to the token that doesn't have this capability? And one way to do that, which is kind of compliant with the architecture of Ton, is to not even try to put this extra logic in a contract, but instead introduce an additional contract that we will call like a time lock. Now, from the token perspective, it has one job, just like O1. So you have a second principle. So this is principle number 1. This is principle number 2. So now the token does one job. The one job is to be able to do transfers. So transfers meaning that communicating with another instance and increasing balances. But we want to do another job. We want to make them time locked. So let's create another contract that does just that. Now the token's owner now is not the wallet, but it is the time lock contract. And the time lock also has an owner, and this is the wallet contract. Now from the perspective of this user, C, it doesn't own the token directly. It owns this time lock kind of proxy contract. And here we are free to put whatever logic we want. We could create this one item saying like that this entire amount is accessible after 1 year, or maybe add something fancy. And whenever we don't need this, we can throw this away and move these tokens directly to the wallet, or connect them to some other contract that implements different rules. Something like time lock version 2, if we find a better idea later. But we don't need to change or break the code of this contract. So how would this work? When the time comes, the user again sends the message, says, I want to transfer the token. It's forwarded to this contract. It says, could you please forward this message to your token? This contract will check the time delay, and if it's all right, then it will forward the message to the token, and the token would continue this operation. So now you would have 1, 2, 3, 4, 5 messages going through this chain of contracts. All right? So that scheme allows you to actually check the second mark. And say that this is O1, and also every contract is doing one job. All right? Yeah, thanks. Now, there is obviously a problem right now, because the wallet now can own all sorts of things. So the wallet may own those tokens, the wallet may own some NFTs, the wallet may own DNS records. Also, it may own those intermediate proxy contracts. And one very common with NFTs is the auction. So from the user's perspective, you would want to see your NFT item on your balance in a status saying it's on the auction, but technically it's not belonging to the wallet, it's belonging to another auction contract. So if you have a user, then the wallet would be controlling the auction contract. That would be the owner of some NFT token or jeton or whatever. But from the UI perspective, the user, of course, wants to see this token on their balance. They see, yeah, it's my token. I probably cannot transfer it right away because it's locked up in this auction. But I have a button to cancel the auction and take it back. Right? So the question then is, how do we make sure that the wallets are aware of all these sorts of intermediate contracts and display properly all the assets that users scatter around the blockchain? Does anyone have an idea how to do that? Well, the reason why we're here is because Ton is a very young network, and all of these things are being kind of created right now. So to give you an example of a design decision that is like not optimal and could be done differently is, well, first of all, this jeton implementation. This was the kind of draft that never went to production, but this is your like first urge to do it this way, because like Ethereum does that. And it took some time to design the system with jetons like that. Then, similarly with NFTs, you need to, like, the wallet needs to be aware of different kinds of like auctions that hold the tokens. And ideally, you would want to have some kind of common interface on those contracts to be able to like index and recognize them even if you don't know the code. And another example of like imperfect design is the wallet v4 contract here. Because the wallet has actually two features. It has ability to send any message from your behalf, but also it allows you to connect plugins. And the way it's implemented right now is the wallet contains a little table of plugins, and there's like good news, bad news. So the bad news, it's not O1. So whenever you add more plugins, and those are meant to be like subscription contracts that are allowed to get to the wallet and ask it to get some money out of it. But like the slight problem here is that as your number of subscriptions grows, your cost of the rent that you have to pay for the contract also grows because your state slightly grows. It's not so bad because the user is in full control, so they know that other users, other companies would not be able to just indefinitely increase this list. But still, it kind of violates the first rule. But it's simple. It's like this. There's a little table, and whenever there's an incoming message to the wallet, you just go through the table, find the sender, see if they're authorized to do the thing, and go on. So it's imperfect, and how to make it perfect is to get back to this pattern of token communication. And this is something that's not implemented yet, but like probably should be done this way. So what you want to have is, say, the wallet has like two features. One is the public key, and another one is through some kind of access token. And the wallet may receive the external message signed by the public key like they do today, or they can receive a message from a trusted token that says, hey, I'm allowed to contact you. Could you please do such and such thing? And then you're able to issue any number of those tokens like this and make the people who are interested in pulling the money out to pay for the storage of those contracts. So now you're not constrained by this list of plugins. Instead, you issue them as tokens, and you may issue even like 1 million of them. And each time you receive a message from it, you just have a constant check that this is your token that you issued, and then allow some operation in the wallet. This allows, again, to scale indefinitely, but again, it increases a little bit of complexity of how to authenticate those tokens. And then the other question is how to remove the plugin, because if you want to unsubscribe, you need to send a message now to this thing. So you probably have to do something like that. Send a message through the wallet to this token to tell it to self-destruct. And then the wallet now the token needs to know about the wallet and allow it to destroy itself. So that's like another example of this, a multi-contract relationship that is allowing us to like shard indefinitely. And yeah, like one job here is to give the authorized access to this entity, and we need like 2 modes because this is controlled by the human and this is controlled by the computers. So like the spirit of the wallet is a thing that allows computers and humans to authenticate some operations on the network, and that would be like the perfectly scalable design. That is also in line with all the like rest of the patterns. So big question here is like why is that so messy, and like how to like wrap your head around this? The reason is that the scalability that you get, where you kind of hit both decentralization and scalability, you're making some trade-offs. And Ton's trade-off here is obviously the developer experience. If you look at Ethereum, it optimizes for developer experiences, but making it like a global computer, just write whatever you want in a traditional sense. So it's very convenient, but it doesn't scale. And Ton reverts this. It says everything will scale infinitely if you bother to implement all these, multi-contract little like boxes interactions, and every transaction is like 5-6 messages. So how do we move forward? Like, what's the outlook for this? How can we make this sustainable for developers and accelerate the development of the apps in a safe and correct manner to kind of guide developers to do the right thing? So we're kind of still in the progress here, and I could tell you about 2 features that are on our minds so far to make it understood. So first thing is what we do with the Ton API. So is Oleg still here? Yeah. So Ton API is a service for developers that makes sense of Ton. There you go. So if you go to like a raw node in Ton network and say, oh, could you please give me some transactions? What you will get is this low-level pieces. You will get those messages. You will get individual transactions on the contracts, and you will have to kind of reconstruct the meaning of these operations yourself. So we want to first introduce a few concepts in Ton API and hopefully make them more standard in the industry that kind of elevate the abstraction a little bit higher. So this is how it works. Let me, I don't know. So in Ton you have messages, and you have transactions, and you have contracts. And I urge everyone to consider each of these things to be low-level primitives that you're not supposed to think in terms of. Like you're supposed to think in terms of them when you dive down in the implementation detail of a contract, but not in the semantics. So if you define your contract semantically, like I want the user to vote in my DAO and receive some profits for some shares, and I have concepts of shares and shareholders and some pool of money and things like that, you should not use those concepts to these primitives to describe your application concepts. You should only talk about them when you dive down to implementation. Why is that? So first, the messages and transactions are actually a part of a chain that has one meaningful action usually. So here, when we transfer a token, for the users, it's just one action. Like I want to transfer a token. So there's user A, user B, and this is just one thing that's happening semantically. And this is what your application wants to do. The application wants to say, I receive a token, therefore I should do something else. This is one logical action. The fact that it's broken down into 4 messages and 4 intermediate contracts is implementation detail. So how do we kind of cross this gap? And we introduce 3 concepts to help deal with this. So one of them is called trace. So this is like simple so far. The trace is a collection of all the transactions that were created by one external message. So whenever you make the initial message here, you sort of like create a subgraph of messages and transactions that could be arbitrarily deep, but at some point it stops. So in Ton, it would look like you have this external message, and then it goes like this as a directed a cyclic graph, and then it stops. So what we do on Ton API, when you ingest the blocks from the blockchain, you group transactions in those traces, and you can request not just the individual transaction for this account. You can say, give me the whole trace of the transaction. So it will give you this raw subgraph of all the transactions that happened as is. So you say, okay, this is the whole thing that was created by this initial message. This is not very useful, but at least it groups things together, because this is actually what happened. Not just this one or that one. This is the entire effect of the transaction. And it's important that those are asynchronous messages that may take some time to create. So this individual contract states may have changed before messages reach them. So this thing is not atomic. It's not like a call graph in Ethereum. It's slowly happening in time and may span multiple blocks and multiple shard chains. So this thing is a snapshot of multiple events and multiple blockchains. But we start from this, and then we introduce 2 high-level terms. In singular. So one of them is called event. So event that was not spent on fees will get back to the originating user, and they may have back something like 0.7 coins. So it will be yet another message and yet another transaction. And if you just look at the raw transactions on the wallet, you suddenly see that some coins left, then some coins arrived, and you don't see the meaning of the whole thing. So events and actions fix this by looking at the entire subgraph and seeing that, you know what, your event is having fee not 0.1, but actually 0.03 ton. That's the total, how much you spent. And it has one action. That's called transfer token. So you have one event over here, and it has one logical action that has a name, because all of this was done to transfer a token. And this is, if you want to like render a transaction list or have a meaningful explanation of some simulated transaction, these are the terms that you would use in Ton API to make sense of all these graphs. What we'd like to have is a kind of more universal description of annotations for these traces so that any developer of the smart contract could say, you know what, I have this composition of different contracts and they have multiple messages around them, and this is how I want them to be presented in terms of events and actions, because I have 7 messages and 10 contracts, I don't know, and for a specific message, what will happen is one event with like 2 actions, like place token, or create a token and place it on auction, for instance. And your description would say, okay, this like creates token, and this is like place on auction or something. So this is like one approach to make sense of this. And another approach is to help express these relationships between the contracts in this smart contract language. And right now we have the FunC, which is pretty low level, where you have to build this by hand and do this, verifications by hand. And we're trying to experiment with a language called TACT. That's in kind of early design stage that tries to figure out how to package up relationship between those little pieces and allow you to write your program that contains multiple different contracts in a sane, kind of compact manner, so you don't have to do many things by hand, and kind of allows you to think in kind of higher level concepts of transferring tokens, receiving tokens, and responding to those events. And it's like a long road, and also things like what does this proxy contract mean is also kind of subject to this, high-level concepts, how we index them, and how Tone API and how the wallets know what you can do with those contracts, and whether those are like proxies that allow you to do something or don't allow to do something. This is also like under construction, and we think that in the long term, if you want to have a successful scalable blockchain, you kind of got to design your systems with all little blocks that do one job and scale as O1 individually, and at the same time develop the infrastructure to help index and design those things. So that's kind of what I wanted to highlight. I would love to answer some questions if you have any specific questions about the subject. There's also Oleg who could comment on how Tone API works. Yeah, sure.
Do I understand it right that actually wallet is extended contract?
In Tone, wallets are contract instances that contain basically the public key and some logic to check the signature.
But what's the difference? It's just index.
So in Ethereum, you have like 2 styles of addresses. One is just the public key, and another one is a contract. And in Tone, it's unified. You have a contract that does the public key check and the signature check, which is just packaged up as a contract. So your wallet address is an address of a contract just like any other. And when you send a signed message here, it's just raw bytes. This contract doesn't know where it came from, and it has to check the signature first before like spending its money on gas to do some other operations. Yeah.
Can you explain a bit about the minter and what its role is? Is that where you do the bookkeeping for total number of tokens?
So someone has to create those tokens. And if you're making a stable coin, this is basically bank. And you can decide that every token knows that they can be created by the minter. So either, like from the perspective of a token, either you receive the tokens from another sibling. So you know that the money was subtracted on one end and increased on another end. Or it allows the message from the minter, so it knows about the minter, it has the address of it. And then it knows that the minter can just create any amount. They are authorized to just tell it, like, now you have 100 items. And says, okay, I now have 100 items. And the minter itself may contain some like total outstanding balance, or And this could be controlled by the wallet, or it could be controlled by some multi-sig contract, or it itself could be some sort of crazy DAO thing that creates those jettons in response to some other events. So this minter could be kind of human operated or programmable. But like the tokens themselves don't care about that. They just have the address of the minter that they trust. Thank you. No.
I was just curious about how the whole architecture interacts with validators in Tom. On which way, on which stage it works with validators.
You mean how the whole network comes to a consensus?
Yeah.
So, okay, I'm probably not the best person to answer this, but the basic idea is that the validators are sharded in groups that are like rotated and like overlapping, and you want to distribute load on the validators so you don't have all the validators validating all the blockchains. So imagine you have like 1,000 validators and you have hundreds, they sometimes may overlap, and you have 10 blockchains sharded out. So you have something like these subgroups of validators, and these validate this shard chain, these validate this shard chain, and all of them, the entire group, is validating the master chain that doesn't scale. So there is a master chain. So you have like a zero work chain in 3 partitions, A, B, C, and you have the -1 master chain that is like centralized, meaning that everyone has to validate it. It's having much more expensive fees. It's like like Bitcoin, like everyone knows about this one, and you don't want to put applications here. Like you can for like managing the validation logic, but it will be very expensive because everyone has to sync on this one. And you're not meant to do consumer transfers. It's just a configuration network, so to speak. So individual validators come to an agreement and consensus on the individual chains and regularly commit their understanding of this shard chain to the master chain, saying, okay, we believe this is the state of the block. And then everyone else knows that okay, these guys achieved the agreement. So in case there is some catastrophic failure and then they make a mistake and commit the invalid block, and some other guys don't even see that, then there is a mechanism for like, first of all, punishing for the mistakes, so you can take off the stake, and second, for rolling things back and undoing the damage. But for the Ton coins specifically, there is a accumulated balance on Ton coins in each shard chain. So even if there is some catastrophic failure, it will be localized here, and you wouldn't be able to create Ton coins out of thin air. So the global balance will be counted on the master chain. And the worst that could happen is that maybe some coins could be stolen from some users towards the others in one chain, but others won't be affected in this manner.
Each event inside the trace should be validated by at least one of the validators.
No. Like this stuff is kind of annotation. This exists. This is the annotation on top of the actual raw transactions. Yeah. So these things are not at the blockchain level. These are the application level annotations. It's kind of like trying to make sense of all these, chains of transactions.
I have a question about reading balances.
Uh-huh.
So the easy one is like if I want to read balance of another user, of how many jettons he has, do I access his wallet or his jetton contract? And if we scale it up, like am I able to pull all holders of the jetton and their balances? Like how do I do that?
That's an excellent question. So is it the question of the like off-chain application that wants to check the balances, or of the smart contract that wants to check the balance? Off-chain? So
in terms of off-chain, you can go to Ton API and use the method to fetch all the holders of jeton. But if you're talking about on-chain application, because it's really important, there I believe no way to fetch all the holders of some jeton. I mean, like securely inside the smart
Yeah.
contract.
Maybe you can go to the master contract and like ask those
Well, probably master contract meter do not know where all jetons he minted located. So this is the drawback of distributed systems like this.
Yeah, I'd like to add some more color to this. So generally in this system, you don't have a global view on anything, and especially because it's also synchronous. So even if you ask this token like, oh, what balance do you have? The minute the message arrives back to you, the balance could be different. So the only way to know the balance is to actually receive the token and receive this notification that it switched to owner, and then your contract is sure that they own this token right now, and then they can do something about it, like do voting. If you, for instance, want this minter to have like administrative access to those individual accounts, this is done locally. Like these tokens may allow extra capabilities for the minter when they send a message to it. And it could be done like going to this contract and saying, could you, lock the money or take them out? And the contract has to implement this logic and say, yeah, like, sure, I can, or not, depending on how it's implemented. But it will be like individual message that comes in and tells it what to do. In Fancy, you may see the get methods that return some data. These are meant for the off-chain use when you're asking the contract, okay, you given some state right now, which may be already like stale, can you compute me some useful data out of yourself? So maybe you have some, packed structure. Could you like unpack it and present it in some reasonable way, like show me your balances or show me like some textual data or something? And these get methods, they're provided for convenience for the off-chain use. The smart contracts cannot call them. Smart contracts only can send messages with money without any reply. So you send the message, just tell the contract what to do, and you don't hear back. You can only hear back if there's explicit message sending some reply to. That's how it works.
Yeah, so I will just clarify it. So you actually can call methods in smart contracts for free. I mean, there are no commission, no fees when you're calling get methods. But those methods could not change anything inside the blockchain. So they could not change any information in the blockchain. But they're very useful. For example, Tom DNS works this way. So you can, like make requests to Tom DNS, and you're just calling some get methods to the smart contract, and you're doing this absolutely for free.
Yeah.
The query is over one the contract, not the whole.
To any contract, actually. So yeah, you have to query exact contract you want to retrieve some data, and there are a lot of limitations inside this part. I mean, like when you implementing get methods inside the smart contracts, you have some limitations. So you could not go to some other contract, ask something else, and then combine the results. So result should be computed inside using the data that the smart contract have itself.
So maybe one question, like if I want to have a state of like how many token holders I have, like increment by one, where is that number stored in the contract?
It's stored inside the cells, right? So you can access those cells using get methods.
Yeah.
So you can make in those examples you can see it there in Dawn Society.
The contract of user A and jeton contract of user B, they share cell, and then
No.
They could not.
Well, let me kind of show you an example. I'm not sure it's a good idea, but what you could do is to say, all right, I want to have a number here that tracks number of users. So every time you transfer the token to a new user, the new instance would be created automatically, would be kind of deployed on the fly. So if I want to transfer one more unit to this guy, then another contract will pop up and appear. What you could do, theoretically, is for the contract to say, is it mine? You could say, okay, when it goes from 0 to non-zero, then it could send a message to the minter and saying, hey, I have a new user, +1. Except this is prone to abuse because, first of all, one user could create 1 million individual wallets and just split up their money. And second, the wallet doesn't have, strictly speaking, infinite life. So whenever it goes to zero, like stops paying the rent, it's going to be frozen, maybe unloaded, and it would like then resurrect with the initial state and could be counted like twice. So on the blockchain, you don't have a notion of like users. You have just notion of individual accounts and where the money is spent. You don't know if all of these are the same person or not. Yeah. Any more questions? Yeah.
Is there a way to identify simple smart contracts wallet accounts from, let's say, more custom smart contracts with some custom business logic?
Oh, sorry, could you please repeat with a new mic?
Yeah. So are there specific standards for wallets? I was wondering, like something like the flexibility. Is there, let's say, a standard for wallet accounts for wallet contracts? And also, is there a way to touch the bytecode, like to distinguish between, let's say, a wallet contract from a...
Yeah, absolutely.
Yes.
So right now there are two major wallet formats that include also description of the code. So not just the interface of the messages, but also the code. They're called wallet v3 revision 2, and the same thing wallet v4 revision 2. So the source code is available, and these are important contracts because if you create another wallet application, it needs to know about these codes so that when you give it the private key and say, hey, can you locate my balance? What it has to do is it has to create from this seed phrase, create a private key. From the private key, create the public key. And then put this public key in one of these wallet states to compute the address of the wallet. And then with this address, go to API or to the node and ask what's the balance of this contract. And it may happen that you have money on like both of these contracts that use the same public key. So effectively, they're accessible by your secret key. But those will be having different code and therefore different addresses. So from the perspective of Ton network, it will be completely two different contracts on the network. So you may have the standard ones, and some users may use some non-standard ones. So you, for instance, if you make up your multi-signature wallet that takes multiple signatures, it would be some non-standard code operated by multiple public keys. You can invent something like that. But in Ton, and this is important for this talk, you really want to build this composition of contracts, and instead of like fitting more features in some contract and allowing the user operate with external messages with different sorts of wallets, you like multi-signature and maybe some time lock, you don't want to do this. Because here you have to verify signed messages from outside, and this is very like error prone, doesn't compose well. Instead, you want to send messages through the normal standard wallet that go to those intermediate ones, and these will be operated by internal messages that are much easier to identify and like authenticate, because here you don't have to check any signatures, you only have to check the address of the sender. And these are composable with all other sorts of applications. So this time lock could work with a wallet, or it could work with some DEX, for instance. And the DEX could just throw the money in the time lock. And this thing would authenticate the request just the same way. And this code doesn't care what contract this is, they only care about the address. So the idea is, if you want to do anything with like verifying signatures with a public key, probably you shouldn't. Maybe your applications should never use any public keys and only use the contract addresses to assign roles and say, okay, this contract address can have this capability and this other address has other capability. And then you can build up the connection between the wallets like with this chain of transactions.
So it's basically composition of inheritance.
Not inheritance, but like a pipeline. Like if you...
Yeah, Just I think it seems that the preferred method is to compose different contracts deployed in different instances rather than using the Solidity model that is a bit object-oriented, like inheriting from
yeah, I see. Yeah. Instead of one monolith inherited contract, you
composing with the
yeah.
other contract.
Yeah, sorry. Yeah, you compose them with this kind of pipeline of like messages. Yeah. So yeah, just keep only those wallets to check those signatures and public keys, and everything else just works on internal messages.
Yeah, I would like to add up that, in Ton, actually, when you operate your wallet with any wallet app, you're just operating in smart contract, nothing special. So it's any wallet in Ton is just a smart contract, and you can go in GitHub and check out the source code of a smart contract you are using. So as Oleg mentioned, right now in operation there are two types of smart contracts for wallets: Wallet v3 and Wallet v4. So Wallet v3 is like this wallet with which actually Ton was launched, and Wallet v4 is updated version, which we highly recommend for everyone to use right now because it supports much more functionality, and it was actually required to build to implement the subscription feature which we launched before, to be able to withdraw some funds from wallet with proper authorization in any time.
Yeah, and brace yourself for Wallet v5. That we will have to do for the reason that Wallet v4 allows plugins to pull Ton coins from the wallet, but doesn't allow plugins to forward arbitrary messages. So the subscriptions that are implemented with Wallet v4 can be paid with Ton coins, but cannot be paid with jettons, for instance. Right? So those you cannot tell the plugin to, okay, could you send the message to jeton? So you have the plugin here. The plugin sends the message to the wallet, and then it has to not just take money out of it, but forward the message to the token here and do this operation. So this is impossible in the current architecture, and we're thinking, okay, when in the future when tokens will take off and you will actually have usable stable coins, and you would like to pay for subscriptions with USDT, for instance, then you would need to migrate your wallet to something like hypothetical v5, where the plugins would be doing two things. First, they would be allowed to just forward any message. So if you want to take Ton coins, your message would say, please send 5 Ton coins to my address, instead of just giving you a number and having hard-coded logic to take the coins. And secondly, it might get rid of this dictionary built in. So the wallet would instead issue those sort of NFTs that will be held and paid for by their proper owners. And if these NFTs die because they're not paid for, it's not users' problem. And then if you want to unsubscribe, you would send a message to this NFT to self-destruct. So we would kind of like break out this dictionary into like separate items on the blockchain, and the cost of paying for your wallet would be fixed. Because right now the rent slightly grows, and if you have 10 subscriptions, then each time you make a transaction through the wallet, you also pay the rent, and suddenly the rent component is more noticeable, and you pay higher fee to maintain this list of subscriptions. And it kind of makes sense for subscriptions to be paid by their merchants, not by the user.
How do migrations work? Is there a concept of upgradability or
Go ahead.
So actually this is an important question, because once this update to version 5 will take place, you will have some UX problems. I mean, like some people who do not know what's happening might have some problems. So most likely Timekeeper will ask you to update your wallet. So some message will pop up asking you to update your wallet, and after you confirm this updating, your address of your wallet will change. So like before you have like previous address, different one, and now you have a new one. And some people could not, like remember this or notice, and still, in case of like they need some transfer, can still provide the old address they had to somebody who is up to send them some funds. And in this case, actually the money is not lost. So if somebody sends some money to your old address, you can just switch the version of smart contract inside Timekeeper. It's actually available in the settings menu, and send funds from your old wallet to the new one. You can do this. Other important thing which some of you might be challenged with is that, for example, you updated your wallet for using seed phrase to version 5, and then you decided to use TonHub with your seed phrase, and TonHub did not support version 5 yet. In this case, you would not be able to access your funds from with different wallet. And you have to keep in mind that it's not a problem. You did not lose your funds, even though if you did not see them in a different wallet. They're still accessible. You just have to, like, for example, send your funds from Timecodes to TonHub to operate with older version of the wallet contract.
So what the wallet application does is that it recognizes that with your key you may access multiple wallet contracts at the same time, and your money could be spread out on them for like good reasons or bad reasons. So for instance, when you migrated from here to here and maybe moved all the Ton coins and tokens over here, but then later this address was in someone's book and they sent you money, or it was blocked in some staking contract and they made a payout later and you received the money here. And so the job of the wallet would be to say, okay, like in Bitcoin, your balance is spread out across multiple addresses, but user doesn't see that. They just see, okay, you actually have liquid amount of 10 plus 50 plus 30 tons across multiple wallets. We can show you this as a single balance, and anytime you want to transfer this money, you don't have to worry about this. If you transfer 5 tons, it will be just transferred from one of the wallets. And then this is a job of the wallet to kind of combine this information in one coherent list. Either you kind of switch explicitly between them, I'm not sure it's the best option all the time, or you combine all of them in one flat list of balances. Like all of your tokens are like across these things. What matters for the user is that you actually have control over them, and whether there's some intermediate instances like these wallets or these time locks is some kind of like under the hood detail. Well, this version 5 does not exist yet, but hopefully it will be the ultimate final wallet until version 6 has to come up, because this would allow you to, well, first of all, anytime you want to do like multi-sig or anything, it would be controlled by the wallet, so there's no reason to upgrade the wallet to support extra features. They would be controlled by the wallet contract. And from the wallet perspective, its job is only to authorize access to itself in some way. And the most generic way so far is to allow signature access and programmatic access from external trusted kind of plugin. And if this part is implemented in the most generic way, right now it's not in the most generic way because the plugin can only take the coins but not send arbitrary message. But if it's allowing to send arbitrary message, and if it scales in 01, it doesn't have the dictionary, then probably it's like the ultimate authentication device. And you can just go with this long term and never upgrade again. Hopefully.
Yeah, I still have a question about private key. Isn't it like, how does it work that you have different public keys, but you have one unique private key for all those wallets?
No, you have one public key here.
So that means that you have like some basic static wallet. And you can build on top of it like some different version of wallets.
I'll explain. So what the contract in Ton is two things. It's all right. So this is the contract. And the address of the contract is the hash of the code plus initial data, like initial state. So the identifier of the contract is the initial data and code, and then data can be modified. Now, what the wallet is that there is some code that does something, like checks the signature and sends the messages. And in the data, it has two things. It has the pub key, and it has a sequence number. And in case of v4, it has a hash table of plugins. So since the code is different, because this one knows about plugins and this one doesn't, and the data is slightly different because this one has a place for plugins and this one doesn't, then the addresses of the wallets will be different, but they will be operated by the same public key. And so if you just know the public key, you may find multiple different contracts on the network that use it. And also you may find some odd contract that uses this public key because they are authenticating some action by it, but like because someone just made it up. It's also possible. Does this answer the question? Okay.
Any more questions? Please don't hesitate. Show your hands.
Yeah, well, to wrap up, we can probably just underline some kind of takeaways from here. So if you build the applications in Ton, the well-designed application would have not one thick contract that does many things. It would have a combination of contracts that work together. Each contract does one job. So let me dig to the takeaway here. So here is the thing. So first, small multiple contracts. Second, O1 execution cost. Like everything has to be paid for, so every user has to pay for their cost, and the cost should be predictable. So strive for constant cost of every contract. So anytime you have to put the hash table anywhere, don't. And if you really must, check that this hash table is either controlled by one party or it has some kind of predictable constant size. For instance, you may have a multi-sig contract where you use a hash table for the list of participants and it's fixed list, like 5 participants or 6. But if it's too big, then probably you don't want a hash table. You instead want to create voting tokens and distribute them among like millions of people and vote with those tokens. And third, it's like Unix principle, one job per contract. And finally, so identify exactly what are the 5 things you want to do in your system, and probably you need 5 contracts that are doing those independent things, especially if they have different roles and different owners. And the 4th principle is use internal messages only. The idea here is external message is not authenticated, so you have to make up your own authentication scheme, which is usually checking signatures, and it's annoying, you may get it wrong, and this is already a job of the wallet, so just don't. And it doesn't compose well if you do the signature checks. But if you use internal messages, then it's super composable because every contract just knows the address of some other contract, and this other contract may be anything. It could be a wallet, it could be some DEX, some robot, whatever. And authentication comes for free, almost. For instance, the jeton will just check the address of the minter and say, yeah, the minter is authorized, or it will check the address of the owner and say it's authorized action to transfer coins. What's not super free, and hopefully the tooling will improve and we will make this expression easier to do, is the relationship between like parent-child and sibling-sibling, where you check that you receive the message from kind of the same instance of your application, just living in another contract. But then it will be still much easier than checking signatures and signing blobs of data. So use internal messages. So that's pretty much it. And also don't forget that there are no read access to the contracts, and don't try to emulate it. So if you want to do the voting and you say, could you send me a message just telling me how much tokens you have? Don't do that, because the minute you receive this message, the reality is different. And you allow yourself to be opening up to like double spend attacks when I vote and immediately sell the token someone else's votes. So no read access, even if you try to build it yourself. You instead have to actually move things around. So if you want to know how much money someone has, this money has to arrive to your contract. You need to know that now it's under your control. You do something based on that, and then you can move it back. So get methods are not available for you, and also don't try to emulate them to implement your application. Just kind of use this object-oriented paradigm of just telling things what to do and not asking them about their state. So that's all I got. Thank you.
Thank you very much.
If you made it this far on this video, I really want to say thank you. If you don't mind, like this video and subscribe to my channel. And also, there's a link to Telegram channel that I have. And once a week at a random day, I'm putting a small checks of ton on my Telegram channel. So you can actually earn some free tons if you are subscribed to my channel, if you're lucky enough to hit this, to cash out this check first. So stay tuned. I'm going to do my best to create more and more useful videos on fancy programming, on ton. I'll take some interviews, so stay tuned, and thanks for watching this video. Ciao.